2, 1, go. So obviously you got a downgrade in your quality of education today because you get me today instead of the wonderfully talented Mr. Roth. He will be back tomorrow, so fear not. You will give me one day. It just happens to be a long day of the week. Okay. A couple of things to talk about before we get going on a couple of warm-ups and then some more unit circle in-depth type things. The lovely and talented Mrs. Hill, again, I don't know why they have me on this. They do all the work, and I just get to sit here and reap the benefits of having them on my team. So she updated the calendar back there. So you get five classes, and then we get a little break, and then after that we come back to some more type stuff. So there, I thought it was in the corner, and I missed the corner. So today we'll talk more about unit circle. Wednesday, Thursday, we're going to talk about the obviosities of the unit circle. Those are the obvious things that the unit circle is necessitating. That's what we call it, obviosities. Friday, now this is important. Friday, you will have a unit circle memorization quiz where we give you a blank unit circle, completely blank unit circle. You have to fill in the angle measure in terms of radians, the radian measure of each angle, and the ordered pair for each of the 16 points on the unit circle. On top of that, you also will have to fill in these the six trig values that go along with those on that sheet. Okay, so that's Friday. Then Tuesday, we'll do some recapping of the obviosities and some finalization of that. And then when we come back, we start some right triangle trig and things of that. And then we'll have a test. I think right now we're looking at the 8th, I think, of December. Yeah, we're already talking December. As you can see, it's very white outside now. Eesh. Okay. So to get into the notes today, so on the unit circle, and that's key. Those 4 words are very key to this slide. On the unit circle. If we are not on the unit circle, then these relationships that we are talking about here do not hold. And you cannot say that the cosine of t is equal to the x value of the point of the ordered pair. And the sine of t is the y part of the ordered pair. Okay? If they're on the unit circle, we can say that. If they're not on the unit circle, all bets are off. Tangent is y over x. And then from there, I go by the philosophy, everything needs a co. Okay? So sine needs a co, so we're going to go with cosecant. Okay? So cosecant is 1 over y. Cosine already has a co, so we're going with the one without a co, and that would be secant. Cotangent needs a co, or is a co for tangent. And then we just reciprocate all of those extra. Once we get into working with the unit circle, which we'll get into that here in about 5-10 minutes, we'll need to know those because we'll have to do some maths that go along with them, some looking at the unit circle, all that good stuff. Okay? So, secondary warm-up problem. Here we go. Okay? First, the question is, I want to know if that point, -7/25, comma 24/25, I need to know if that point is on the unit circle. Because if that point is on the unit circle, then we can find the 6 trig functions for it. If that point is not on the circle, then we just say, nope, sorry, not on the circle, and we sit there quietly until we're ready to go with the answers to this problem. Okay? So at this time, I want you to verify that that point is or is not on the unit circle, and then if it is, find me the 6 trig values of that. So to first verify it, we have to make sure that it fits the equation of the unit circle, and that is x squared plus y squared is equal to 1. So I need to square the x component, -7/25. I need to square the y component, 24/25. And hopefully that in the end then is equal to 1. -7/25 is 40, or squared is 49/625. 24/25 squared is 576/625. 576 plus 49 is 625. 625, which is equal to 1. So 1 is equal to 1, so that point is on the unit circle. Now, that I know that it is on the unit circle and I have verified it, the cosine of t, of that angle, of that point, would be -7/25. Which means the secant of that point would be -25/7. Just the reciprocal of it. The sine of that angle would be 24/25, which means the cosecant of that angle would be 25/24. The tangent of that angle, well, I'm going to have to take y and divide it by x. Fraction divided by a fraction, keep, change, flip. So I'm going to keep 24/25. I'm going to change division to multiplication. I'm going to multiply by the reciprocal. I'm going to flip the -7/25. These cancel each other out, leaves me with -24/7, which means the cotangent will be -7/24. Questions on that? Now, I know that you have 1, maybe 2, some of you might even have 3 or 4 unit circles in your notes. But because the Friday's quiz is going to be a memorization one, let's build another one together. Okay? Okay? And we'll go through it again. So start with a circle. And then add your crosshairs. Now for me, I build quadrant 1. Because then from quadrant 1, I can reflect across the y-axis to get quadrant 2. I could reflect that across the x-axis, and I can get quadrant 3, and then I can reflect that whole top side on the bottom. Okay? So I can get all 4 quadrants just from quadrant number 1. So we'll start with the easy ones. And then I've got the halfway. I don't even want to know. And I've got the other 2. Okay. I'm going to start with the points. Now again, I've been doing this longer than you have, so I've got certain things memorized already and I've got it committed. But if I were doing this the first time, I would probably want to know what the actual value of the square root of 3 over 2 is. And when you divide out the square root of 3, or when you take the square root of 3 and you divide it by 2 on a calculator, you get 0.86625. Okay? So that is close to 1. Okay? So, or closer to 1 than 1/2, which is just 0.5. So that's why I know that the purple point is square root of 3 over 2 first, 1/2 second. The red one up here is higher up, so that's only 1/2, comma, square root of 3, 2. And green is root 2 over 2 and 2 over 2. Now, there's patterns about it. Okay. One of the patterns is the 0 to 4 pattern. Okay. We'll do x's coming down. 0, 1, 2, 3, and then 4 divided by 4 is 1. Okay. Y's could be going the other way. 0, 1, 2, 3, 4. Okay. Another one is if you take your left hand and you hold it out, it kind of makes the 5 points that are in quadrant number 1. Okay? And so if I take, now this doesn't work on the extreme ones, okay? But if I take, so like this one right here, that's this point right here. So the x part would have 1 in it, the y part would have 3 in it. If I take the green one, the x part's going to have 2 on the x, the y part's going to have 2 on the y. Okay? So there's multiple different little patterns, little nuances that you can see if you choose not to just straight up memorize. Okay? So then now we reflect over here. Well, that one becomes negative 1 comma 0. This one becomes negative square root of 3 over 2, comma positive 1/2. This one becomes negative root 2 over 2, positive root 2 over 2. And this one becomes negative 1/2 square root of 3 over 2. Then I can reflect that whole thing down to the bottom.
then lastly, oh, it's purple. No, I did purple already. Red. Scroll down just a little bit. And now, again, on Friday's memorization quiz, you'll need to know the gradient measures for all of them. Okay? So we start at 0, we go all the way around, and that's 2 pi. Half of that would be pi. Half of half would be pi over 2, which would make this 3 pi over 2. Half of half of half is pi over 4. So I went 1 pi over 4, 2 pi's over 4 gets me down to 1/2. 3 pi over 4 is that one. 4 pi over 4 is 1. 5 pi over 4. 6 pi over 4 is my 3/2 root. I guess I forgot to label that 0.2 as 0, 1. And then we've got 7 pi. The other ones, we get to count by sixths for all of them. So this is pi over 6. This would be 2 pi over 6, which is pi over 3. Straight up would be 3 pi over 6, which reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 reduces to 5 pi over 4, or 5 pi over 3. 11 pi over 6, and then 12 pi over 6. So there's our unit circle. So that, on top of this, will be what you need to have memorized by Friday. Okay? Let's put it to work. So now knowing on one of your unit circles, okay, the cosine at 3 pi over 4. Well, we said earlier in the class that cosine was the x value. So what is the x value of the point with an angle of 3 pi over 4? Anyone? X part of the point? Negative root 2 over 2. Tangent, we said, was y over x. The y value at 3 pi over 4 is root 2 over 2. The x value is negative root 2 over 2. And that would reduce to be what? What does that reduce? Just you got it right. -1. Yep, -1. Because it's the same. One's positive, one's negative, so it reduces to -1. No different than x divided by negative x. Or b divided by negative b. If you didn't see it, keep, change, flip it. Keep, change, flip. I got a square root of 2 on both top and bottom. Those cross out. I got a 2 on top. I got 2 on the bottom. Only thing that's left over is the negatives. Okay. With that being said, you do the next two. Tangent at 5 pi over 3 again is y over x. So 5 pi over 3 has a y value of negative square root 3 over 2 and an x value of 1/2. Keep, change, flip. Is going to give me that value is negative square root of 3. Secant at pi over 6, everything needs a co, so that is 1 over the cosine of x, or cosine of t, I should say, so it's 1 over x. Pi over 6 has an x value of square root of 3 over 2. Keep, change, flip, or just reciprocate it, gets me to there, but we like our denominators rationalized. On the unit circle, we rationalize our denominators. So we're going to have the square root of 3 over the square root of 3, which is going to give us 2 square roots of 3 over 3 for that. Okay. You don't get around rationalizing. Okay. Scroll down just a little bit so they all get in there. Go for it. So cotangent is x over y of 3 pi over 2. The x value is 0. The y value is -1. So the cotangent at 3 pi over 2 would be 0. Agree? What would the tangent be at 3 pi over 2? What would the tangent be? We call it undefined. We would say undefined because we'd be dividing by 0. It would be -1 over 0. It would be -1. Cosecant, everything needs a co, so that's 1 over the sine. The sine is y at 3 pi over 4. So that's going to be 1 over the square root of 2 over 2. Keep, change, flip. Or just reciprocate for that matter. 2 over the square root of 2. Rationalize your denominator. 2 over 2 gives me 2 root 2 over 2. That crosses out. Gives me just the square root of 2. Cosine at pi over 3. Well, cosine is x. Secant is 1 over x, and cosecant is 1 over y. Okay? So the x value at pi over 3 is 1/2. So this would be 1/2 quantity squared. 5 pi over 6 has a secant value of 2 over the square root of 3. And we need to square that. Cosecant at 7 pi over 6, the reciprocal of that would be negative 2. And we need to square that. 1/2 squared is 1/4. 2 over the square root of 3 then squared is 4/3. Negative 2 squared is 4. Common denominator them all. Three plus 16 is 19. 19 minus 48 is negative 29. And all of that is over 12. Questions, comments, concerns, clarifications? Now it's time for you to practice. I have a worksheet here, a 4.1 trig values, or actually not 4.1, a 4.3 trig values worksheet. As you're looking at the board, you probably noticed the little note that I put up front now. And starting with this section or with this unit, now all homework is optional if you are getting above an 83%. If you are getting below an 83%, your homework is still mandatory. Okay? But if you're above an 83%, now you have the option to turn homework in.